Good evening, everyone. Am I audible? And I have shared my screen. Kindly.
Good evening, ma'am.
Yes. Is my screen is visible, people?
Yes, ma'am.
Great. Let's wait for 2 more minutes for others to join. Then we'll start the session, people. All right, people, I'll start the session now. So the first question is we have to consider a graph. So before that, what is graph, people? Do you all remember what we have discussed in the previous session? Yeah, people, please do respond.
Sorry, ma'am. Can you repeat that graph thing again?
Yeah, sure. So first, actually, it is a graph in the sense of like how it is connected, like how one vertex is connected with the other vertex. Vertex in the sense of, let's say, I'm taking up a node here. Okay. Let's say this is the source. So from here, I have to reach some point. Let's say I'm starting from my home. From there, I need to reach the college or some other place, or let's say mall or somewhere else. So this is the destination. So what are the ways to reach it? Will there be only one way or will there be a multiple ways?
Multiple way, like.
Of course. So to reach a destination, there will be a multiple ways to reach it. So similarly, here also using a graph, we can represent it. Okay. So let's say I'm going from the source to destination. Let's say one destination will, I mean, like one path will take, let's say 10 kilometers. The other path, let's say it is taking around 12 kilometers. The other path is taking around, let's say I'm going like this way. So this path is taking around 20 kilometers. Okay, so these are the ways to reach. So I can represent this weight also. This is said to be a weighted graph. Okay, and next is we can represent it using a dictionary in a matrix representation, which means let's say I have a 5 cities. The city named first is A, and there is a city named B, city named C. Okay, so from A to A, of course, I'm not going to go through the same city, right? So let's say it's 0, 0 and 0. So now, is there a path from A to B? We have to check. Let's say this is A, this is B, and this is C. And here there are of two types. One is of a directed graph and the other is of a undirected graph. Undirected in the sense of it's a byway. It's a two ways. Like from A to B also I can go. From B to A I can reach again. So that is said to be a undirected graph. Directed in the sense of this is said to be directed, which means it's like a one way. From B to C I can go. I cannot return from C to B here. Is this clear, people?
Ma'am, I haven't started the week 9 yet, so I'm not able to understand it so much. I'll do it tomorrow.
Okay. So actually we have discussed in the previous session, right? So that's why I have just started like this. It's okay.
Because
We can discuss again.
we have the quiz tuna, so I was not able to do the week 9.
Got it. Got it. Not an issue, Ma. Well, I'm discussing the same steps again. Okay. So let's
Okay.
see. From A to C, there is a path, right? So from C to A, I can go. From A to C, is it possible to go in this path? A to
Yeah.
C?
No, no.
Exactly. So I can just fill it as A and B are bidirectional. A to B also I can go. From B to A city also I can be able to reach. Then is it possible to reach from A to C now?
Yes, now it is.
Using this path I cannot reach, right?
No, no. You using that, not we cannot reach.
I can just use a different path, but using that path, let's say it's not possible. So I'm giving it as 0 initially.
Okay.
Okay. And then let's say B to B is not possible. Then B to C, is it possible?
Yes, it is.
Is it possible to
Yes,
travel
ma'am.
from
Yes,
B to C?
yes, yes,
Okay.
ma'am.
Okay. Let's say I'm giving like this. Now, is it possible to travel from B to C?
No, no.
Exactly. So now let's say I'm giving it as 0. Then C to A, is it possible?
No. Yes, it is. C to A.
It is, right? Because you can see the path here, right? From C
Yes,
to
yes.
A,
I
is a
can.
path. Then C to B, is it possible?
Yes, ma'am.
Yeah. So this is what is said to be. We are representing it using 2D matrix.
Matrix.
Yeah,
Uh,
it's a matrix representation. Okay. So in matrix representation, we can just use the dictionaries to represent it, which means, let's say here I have to create it 3 nested dictionaries, right? The first
okay.
dictionary is to denote the vertex A to the other vertices. This is for B to the other, and this is for C to the other, right? So the next thing is this line is said to be the edge, and this A, B are said to be the nodes or the vertices.
Okay.
Is this clear?
Yes, ma'am.
Great. So similarly, let's say there is a method named create of. So if they have just mentioned this create of n comma n in the sense of we have to create a matrix with the size of n comma n. N is let's say 3, which means I have to create a 3 cross 3 matrix, which is the size of it.
Okay.
Is that clear, people? If the n
Yes.
value is 4,
What?
if the n value is 4, then we have
So
to
four,
create the,
6, 4 by 4.
exactly, we have to create a 4 cross 4 matrix there. So whatever is the dimension they have given, based on which we have to create it. Is this clear, people?
Yeah.
Okay, what does mean by a diagonal value? Primary diagonal and secondary diagonal?
Uh, pri- Primary diagonal means A comma A or B comma B or C comma C.
Yes.
Or
This is said to
second
be the diagonal values, right? Let me just use. So
yes,
secondary diagonal in the sense of C,
C A.
yeah, this is
Okay.
said to be the secondary diagonal.
Okay.
And this is said to be the primary diagonal. Okay. And how about the indexing, people? Generally in a list, how do you represent it? How the vertex starts?
Uh,
In case of a list, let's say I'm giving the list values is 1, 2, 3. What are the index values is over there?
um, like
If anybody remember that, people?
Yeah, that row into columns. So 0, 1, 0, 2, like that.
Yeah. So similarly, in case of a list, we'll say it as 0, 1, and 2. That is said to be the vertices. Here, we'll say this as a, like it's like a row and column, right? So A, B, C, this is a first row. Am I right, people?
yes,
And this is of a second row. So these are said to be the rows. And how about these? A, B, C?
columns.
Exactly. So these are the column values. So generally, if the a number values, let's say I'm telling it as a 1, which means it's a position value. So 1, 2, 3 are the position values. 0, 1, 2 are the index values. Is this clear, people?
Can you explain it once more, ma'am, about the difference between index and the other values?
Position is nothing but how we count. We count from 1, right? It's like a normal human counting, dear.
Okay, ma'am. Okay.
Like how we will count. We'll just count it as first row, second row, third row, something like that, right? But in case of a programming, we have to count it from 0. Okay, it takes the value from 0 to n minus 1. N is nothing but the whatever the value is. Okay, let's say
Yes,
if the
ma'am. Got
value
it.
is, if the n value is 3. So what can be the possible index values?
0 to 2.
Exactly. 0, 1, 2 are the index values. Okay. Because we have to take the index values from 0 to n minus 1. Is this thing clear to you?
Yes, ma'am.
Great. Now tell me the index values of this 0, comma 0, 1, comma 1 and all.
So first would be 0, comma 0. The first element AA would be
Yes.
0, 0.
Okay.
The then B, B would be 0, comma 1 and C would be 0, comma 2 for the first.
Yes, perfect. It is nothing but this is 0, comma 0 because this is of 0th row. So it is like 0 and 0. And how about the columns? This is 0th column, first column and second column. So 0, comma 0, 0, comma 1 and 0, comma 2. Is this clear, people?
Yes.
This is of first row and this is of second row, which means row comma column, right? You all know, right? Like how will we represent? We'll represent as R comma C. So first row, 0th column. First row, first column. First
Okay.
row, second column. And here, second row, 0th column. Second row, first column. Second row, second column. Is this clear?
Yes.
Now, how to take the primary diagonal values?
0,
These
comma
zeros
0.
these zeros, right?
Yes,
Is-
which is nothing but whatever is the R value, it has to be the C value as well. That's what we are
Yeah.
taking as your diagonal values, right? And also these diagonal values we can take only from a n cross n matrix. What does mean by n cross n?
Where I goes
Same
from
now.
0 to n minus 1 and j goes from 0 to n minus 1.
Like it's like a square matrix. So square matrix in the
square.
sense
Yes,
of
yes,
number of
square.
rows is equal to the number of columns. Is this clear?
Yes.
Everyone?
Yes, ma'am.
Great. So how about the secondary diagonal people?
It's 0, 0, 1. So it's 0, 2, 1, 1, and 2, 0.
It's actually 0, 2,
R
1,
minus
1,
2,
2,
C.
0. So here I have just easily given the notation as whatever is the R value. If that is equal to a column, we can just take it as a primary diagonal. Then how about this one? How to give this notation here?
R minus R equals to C minus 2.
I didn't get it. Could you please repeat?
R equals to R plus 2 comma, sorry, R comma R plus 2.
R is equal to R plus 2,
Sorry, I'm not giving the right answer.
which has to satisfy all the cases, right?
Yes.
Others, just give your idea, people. It's not about it has to be correct. Just give your view on this.
So is it like R plus C by 2? C R plus C by 2 is 1. R plus C by 2 minus 1?
No, actually it is like, let me just use a different color here. R plus C has to be equal to n minus 1. What is the
Okay.
n value for this?
3.
3.
It's 2, 2, 2.
N is equal to 3. So n
3.
minus 1 is nothing but 2.
2.
0 plus 2? 2. 1
2.
plus 1? Again
2.
a 2. 2 plus 0 is also again a 2. So you can just use for secondary diagonal, you can just mention like this. R plus C is equal to n minus 1. Is this clear, people?
Yes.
Yes, ma'am.
To everyone?
So then this 1, 1, how it will be satisfied actually?
1
R
plus
plus,
1?
yeah, so 1 plus 1, 2.
Huh?
Then n minus 1. N
N
minus
is
1 is a
3.
square matrix, huh?
Yeah. This
Okay,
always can be done only in a square
square
matrix.
matrix.
So
Okay.
that's why we are just taking whatever is the R value, if that is added with C value, which has to be equal to n minus 1. N is nothing but the size of a square matrix.
Okay, got it. Okay.
And similarly, R is equal to C has to be for the primary diagonal. Is these things clear, people? Or people, do you want me to pass here for a few minutes for you to understand all these things?
It's
No,
fine.
ma'am, you can continue.
Okay. Others, is that fine?
Yes, madam. Go forward, madam.
Yeah, great. So next is, let's say we have a graph. Let's take elements like A, which is connected to B and C and D. Okay, let's say A is connected with A and C. And B is connected with A, C, as well as, let's say I'm giving like this. So in this, whether all the values are connected with all the other edges?
No, because A and D are not connected, right?
Exactly. So this is here, if what we can say here is this BCD. How about this BCD?
Yeah, yes, it's
Connect.
connected.
Yeah, here it satisfies the condition that B is connected with all the other vertices. Similar with C. C is connected with all the other vertices. The similar is applicable to D as well. So this is said to be a clique. So what is meant by a clique? Which has the same similarities. Okay. So if all the edges are connected, this is said to be A and C.
Symmetry, I think.
And B connected with A, C, as well as let's say I'm giving like this. Yeah. Let's say here A is also connected with D. Now, so in this,
Now
yes,
all of them are cliques, right?
yes. So here all the vertices form a clique. So previous one and this one, what is the difference now, people?
So here
What
you
change
have,
to make all the elements to be a clique?
okay, so that all the elements are connected with all the other elements.
Yes.
So here,
So for that, what I did is I have just added only one edge to make it the whole element as a clique. Is this thing clear? Okay, I have added only one edge by which I can be able to make the whole element as a clique. Got it?
Yes, ma'am.
Great. So this is this A, B, C, D, whether this is a directed graph or an undirected graph. Yes, please repeat.
Directed.
Exactly, it's an undirected graph because I haven't given any directions to it. So that is said to be a undirected graph. Okay, so let's say, how will you, let's say if a vertex is said to be a clique, how can we say the vertex is said to be a clique in general terms?
If it is connected to both
it is connected to all other elements, all other vertices.
Exactly. It has to there has to be edge which has to connect all the other vertices, which means let's say this is said to be 1. So this has to be connected with the remaining 3 vertices, right? That is vertex 2, 3, and 4. Is this right?
What
yes.
happens? It self connects to itself.
Yeah, let's say A is connected with all the other vertices. So now, if I'm taking A has to be connected with all the other vertices, which means remaining 3 vertices. Yes. So how
Ma'am,
many
can
edges the A
A,
has?
yeah, it has 4, right?
How many
Sorry,
edges?
3, 3, 3.
Exactly. So similarly, how many edges the B has?
3.
3 again.
3. Sorry, about C, the same 3 again. For D, again the same 3. Okay, it's like, what is the end value? The number of vertices is said to be 4. So the number of edges is n minus 1. If a vertex has n minus 1 vertex, sorry, n minus 1 edges, then that is said to be a clique. Is that clear?
Yes.
Is it clear to you all?
Yes.
Others?
Ma'am, I have a small question here. So what if A connects to itself?
That is said to be a cycle
Okay.
because it is itself, it is just rotating. The same city I can just go and reach. It's like a loop, right?
Yeah. Yeah.
I have a doubt. Should I watch the lecture first? Then I come to this week.
Himanshu, are you saying something? Because your
Yes,
voice is
ma'am.
still low.
Hello.
Yeah. Tell
I
me.
was saying that should I watch the lecture first so that I can understand it?
Yeah,
Because
that's
I'm
why I'm just giving a summary now.
okay. Summary. I know I'm getting a little, but not the whole point.
Okay, what's your doubt in that?
Uh, Doubt is nothing, but I think I should watch the lectures, then I should come here. I'll watch it tomorrow and I'll watch this lecture again on YouTube.
Okay. So, will you be unable to understand any topic so far?
No, I can able to understand it, but in my opinion, I think I should go because if we are going to do questions, I'm not able to understand them.
Okay, okay. It's okay, we'll just do the questions again, people. Actually, these were all completed in the previous lecture. That's why I have just telling the glimpse of it. Anyway, I'll just do the questions again, not an issue.
Can I?
Okay. So, not an issue, people. Okay.
Yes, I'm not an issue. You are explaining good, but I am.
No, I'm saying that I'm just going to explain the topics again as well.
Okay. No problem.
Okay, do you want me to start from the week 9
No.
from starting or?
No. I don't want. I want you to continue from that point.
Okay, yeah, that's fine. Give me a moment. So, people, do you have any doubt in undirected graph and clicks?
No, no.
Okay. Do you all understand what is that directed graph and undirected graph? That one?
Got it now.
Okay. And people, if you want me to go in a slower pace also, please let me know.
Excuse me, ma'am. One more doubt for me.
Yeah, please say.
Yeah, actually, once you explain now how we can say vertex is a clique. In that something n is equal to 4. You explain no, that is the vertex. So
Yeah.
when we will n minus 1, just you explain no. Can you explain one more time that?
Yeah, sure. Let's say A is a vertex, B is a vertex, C is a one more vertex, D is a one more vertex. So how many vertices are there?
4 vertex.
Okay. And A has how many edges?
3.
Exactly. And B has how many edges here?
3.
And how about C and D?
3.
Exactly. So here, if a vertex which has n minus 1 edges, n is
Okay.
nothing but the vertices,
Thank you, ma'am.
then we can
Understood.
see it as a clique. It's not only
Yes.
about this. Let's say A and D are not connected. Then how many edges for a A?
1.
No, 2, right? This is first one. This is of second edge.
Yeah.
How
A and
about B? How many edges a B has?
when it is not connected to?
For this graph. I hope my screen writings are visible, right?
Yeah.
Yeah, now tell me how many edges A has?
2 edges.
Yes. How about B?
B 2 edges.
How about C?
B is 3.
B is only 2. Yeah, B is 3. And how
Yeah.
about C?
C is 3.
How about D?
3. 2.
No, only 2, right? Okay.
Yeah.
So now what I need to do is, here I am not able to find all the vertices or the clique. So what I
Yeah.
have to do is, I have to check which are all connected together, which means the similarities. Let's say I'm going ahead with the A vertex. Whether A is connected with B,
Yes.
whether A is connected with C,
Yes.
A is connected with D, no.
No.
So I'm just leaving this, and I'm trying to check all the other vertices now. Whether B is
Okay.
connected with C,
Yes.
yes. B is connected with D,
Yeah.
yeah. So now I can just take a B for a moment, and then I'm taking C. Is T is connected with B and D?
Yeah.
And similarly, I'm checking with D as well. Is D is connected with B and C?
Yes.
Yeah, so I can just say only these three forms a clique out of all the four.
Okay.
Okay, so in the given graph, we can find a clique as a part of it, or we can just say the whole graph is a clique also. It's based on
Oh,
how many edges it is connected.
okay.
Is this thing clear, people?
Thank you, ma'am.
Yeah. Okay, and one more thing is, I'll just show this one. Yeah, this is what I have mentioned, people. So whenever they have given a create
Madam,
matrix.
sorry to interrupt, but this
Yeah,
is same for the edges also, right? So how many, for example, this many vectors means how many edges required, now that also n minus 1, same way, right?
that is what I'm mentioning. So vertices is this is of edges.
Okay, that n you are talking about only the vectors only. Okay,
Yes, yes, yes.
okay.
Okay, great. So next is of a create matrix. So create matrix in the sense of, let's say they are taking a nested dictionary. Okay, which means let's say this is of 0th row and next is for first row. Okay, or else let's say I'm taking three rows here. So this is of 0th row and this is of first row and this is of second row. So this whole is enclosed in the another dictionary. So the 0th row has, let's say, 3 columns. So it'll have 3 different values. Okay. Similarly, B also, let's say it has 3 columns. Yeah, sorry for the interruption. So let's say B also has 3 columns. So we have 3 different values and this is of a column. Okay, so first this indicates a row inside which we have a column differentiation. Is this thing clear, people? Yes, everyone?
Will you tell it again, ma'am?
Do you want me to repeat?
Yes, ma'am, because it's getting confusing.
Okay, wait. Let's say I'm taking a matrix with 1, 0, 1, 1, 1, 0, 0, 1, 1. This is the matrix. Okay, so how will we iterate through? First, we'll go through the 0th row, then we'll go through the first row, and then we'll go through the second row. Is this thing clear?
No.
Yes, ma'am.
Okay, so now how will you write it in a code in the sense of? So first thing is I have to write 1, 0, 1. So this is the 0th row, all the other elements were written. Then other values are 1, 1, 0. This is of first row, the remaining 3 values were written. And next is of 0, 1 and 1. So how about this? This is of second row. Is this clear?
Yes, ma'am.
Which is nothing but, generally if I write a dictionary or a set, whatever is the first element is said to be the 0, right? Index value is 0. Second index is 1 and the next index is 2. So this is what I'm writing it as a outer one, inside which we have a different elements. Different set of elements here.
I have a question here.
Yeah,
So,
please.
in a when we make a dictionary, we assign a key value pair, right?
Yes.
So, what would be the key and the corresponding value for that following key here in this dictionary?
0 is it's like 0 and its key values are 1, 0, 1.
Oh, okay. Got it. Yeah.
It's like a row is taken as the first one and the columns are the other ones. Is that clear? To everyone?
Ma'am, can you just repeat that sentence you said?
It is like first is the 0 is the row and the column values are taken. Similarly, I have a first row. What are the column values are there?
110.
1, 0. Yes, 110. And next is of 2. Second row, what are the values are there?
11.
0, 1, 1, right?
Mhm.
Here you cannot take it like a numerals. Here we have to take it like the index and position values. Is it clear?
Yeah.
Great. So now moving to this program also, here you can find that what is the I value initially?
0.
0. So which means in 0th row we are going to iterate for the, yeah, can you see here? 0 is less than rows. Because let's say the number of rows is 3. So 0 is less than 3, condition is true, it will enter into this looping. So here the j value is said to be a 0. Then matrix of I, which means whatever is the I value, like they are taking that as an index, like whatever is the value that is taken, equal to a empty dictionary is created. Inside which what they are trying to do is j value is initialized to 0. What is the number of column value here? Let's say that is also equal to 3. So 0 is less than 3? Yes, the condition
Yes.
is true. So here matrix of 0 comma 0 is said to be a 0 element and j is incremented. What is j?
0.
Previously 0, now added by 1, it becomes 1. So we have to check whether 1 is less than 3.
Yes, it is.
The condition is true. So 0th row, first column, the value is said to be a 0. Then j is incremented by 1, which means what is the previous j value? 1. 1 plus 1 now becomes 2.
2.
So 0 comma 2. We have to check the condition as well here, that is whether 2 is less than 3. Yes. So that value is defaultly set to 0. Then j becomes 3. Is 3 is less than 3?
No.
No. So the condition stops here. Because the condition fails, the loop stops here. Then after this loop is over, I value has to be incremented. Now what is the current I value?
1.
Yes. So previously it is 0, now it become 1. Now 1 is less than 3. Is the condition is true?
Yes.
So again, j is initialized to
0.
0. Is 0 less than 3? Yes. So 1 comma 0. First row, 0th column is set to be 0. Then j becomes 1. Is 1 is less than 3?
Yes.
So first row, first column value is set to 0. Then j is incremented to 2. Is 2 is less than 3?
Yes.
Condition is true. So 1 comma
0.
2 is set to 0. Then j becomes 3. Is 3 is less than 3? No. So the loop stops. As the condition fails, the loop stops. Then I is incremented to 2. Is 2 is less than 3?
Yes.
Condition is true. So again, j is reinitialized to 0. Is 0 less than 3?
Yes.
Yeah. So second row, 0th column is set to be value 0. Then
2, 1 will check 0.
yeah, 2 comma 1 is set to 0. Then
2, 2, 0.
and then I value becomes 3. Is 3 is less than 3?
Nope.
No, the condition fails, so the loop stops. So this is the way to create a matrix. Is this thing clear, people?
Yes.
To everyone?
Yeah.
Great. So generally, a value is in default, it is set to be 0. Okay, so when I'm creating a matrix, the default value is 0. So how about this? Is it a square matrix?
No.
No. No, man. No.
Yes. Square matrix.
Exactly, it's not a square matrix because what is the row value here?
30.
30.
Yes, so the row
Column
value is
45.
30 and column value is 45.
45.
So this is not a square matrix. A matrix is said to be a square matrix when the number of rows has to be equal to the number of columns.
Column.
Any doubts so far, people?
No. No.
Okay. So this is how we are just trying to create a matrix in this. Okay. Yeah. Now tell me what they are trying to do in this.
Some of the matrix, I think, rows and columns.
All the values were taken, or is there any specific condition is given?
Condition is when C
Equals
is
to R.
equals to R, column is equal to R, row.
Which means
We are trying to find the sum of the
Here
diagonal.
only sum of the diagonals here.
0,0 times.
exactly, excellent people. Here what we are trying to do is whatever is the column value, the row has to be equal to same. Then I'm adding the values, which means I'm trying to add only the primary diagonal values. Okay. What does mean by upper diagonal matrix and what is said to be upper triangular and lower triangular matrix?
Means
So when we cut matrix in horizontal with the diagonals, and the lower triangle is called lower and upper side is upper.
yes,
I'm here going from upper top to
upper face
lower bottom. 1 1 1.
Yes. Now tell me people whether A is upper triangular or B is upper triangular matrix.
A.
A is an upper triangular matrix because of the zeros point, the edge of the vertex points upward.
Okay, others?
A is upper triangle.
Okay.
The euro mark is
Yes. Perfect people. So actually this is said to be the upper triangular matrix, right?
yes,
Yeah, because you can see this, right? Like after diagonal, the one element is at the top. So that is said to be the upper triangular matrix. Okay. Leaving this triangle, all the other elements are one in the sense of that is said to be the upper triangular matrix. And B is said to be the lower triangular matrix.
I remember that these are things in the 12th class mathematics.
Yeah, the same thing.
Now I'm getting a lot of.
Madam,
Fine, great.
this matrix, can you undo, madam? So, can you show me? Yeah. So here all will be the Boolean value only. It will come matrix here 0 1 only. So no other value, right?
No. The upper triangular matrix, here it can be 4, something like 7. Here I can just give it as 9, 11,
Okay.
12,
So-
something like this.
So you used only 0 1, no? That's why I asked this one. Maybe it's
Okay,
only
okay.
the Boolean.
It's not like that. Only this particular value has to be 0. Remaining other can be any other elements. That is non-zero element.
Yes.
So the upward sharp corner means it's upward and
Upper triangular, and downward if it has that sharp edge in the sense of it is lower triangular matrix.
but we will only select for the 0 only. How it will be actually? Or is it any value? Maybe you just
No. It has to be 0.
It has to be 0.
This triangular part has to be 0. Remaining, leaving this, all the other element has to be a non-zero elements. Then only we'll say it is an upper triangular or lower triangular matrix.
Okay, if all maybe for example in A, these 3 zeros available, maybe it will be available 1 1 1 means then no triangles in this, right?
Yeah, this is not said to be a diagonal upper triangular matrix.
Okay, got it.
Only this triangular part should form a 0.
Okay, got it, ma'am.
Okay, others, do you have any doubt, ma?
No, ma'am, no.
Great. Then proceeding further. So this is a summation of principal diagonal or primary diagonal values. So can you see here, they have given if the C value is greater than 0. So generally what the array positions are 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1 and 2, 2. So in this they are saying if C is greater than R. So where the C is greater than R?
0,
It's
0,
a lower
1, 1,
triangular
2
matrix.
and 0, 2.
In the
Yes,
lower.
Yes.
No, it's
Here C is greater than R, right?
yes.
We are making this to 0. Here R and C. C is greater.
0.
Make this as 0. Here is the condition is satisfied that a C is greater than 0.
No, it's not.
Here is the condition is satisfied.
No, it's not.
No.
No. So we have to leave this. Then 1, 2.
0.
Yes.
Make
This
it
is
as
creating the
yes.
lower triangle.
So that's it, right? So this is said to be a lower triangular matrix. Is it clear, people?
Yes.
To everyone?
Yes, ma'am.
I've got a doubt.
Yeah, please.
If instead of MRC, can we have MCR like column and then row? Like in the code?
Yes, here as it's a square matrix, it will not create any issues. If it is not a square matrix,
Then it will flip.
yes, it will just give some wrong index positions.
Okay, ma'am.
So here it's a square matrix, it doesn't make any sense. Both are like, we'll just able to get that index element. Okay.
No, coming to
Yes,
Najat,
ma'am.
madam, see the same question.
Hmm.
If matrix, the first bracket it's represent for the row and second bracket is represent for the column,
Yes.
or we can shuffle.
If I'm
Yes.
shuffling also, let's say I'm giving like this. So this become the rows index and this become the columns index.
Okay, so which means in syntax, the first one is a row, second one is a column.
Yeah, it's default. You
Okay.
may change a variable, but
Yeah, got it.
it has to be the row and column only.
Okay.
Got it, right?
Yes, madam.
Okay. So cliques, is that clear to everyone? Which means it should have a similar elements. Like the connection has to be a similar one.
Okay.
So for that only I have mentioned if there are of n vertices, there has to be n minus 1 edge for all the vertices. N minus 1 edge for each vertex, let's say. Then that is said to be a clique. Is that clear? Here, based on the similarities, we are just connecting it. So can you see how many edges of a clique of n vertices will have? Which means, let's say A, B, C and D is there. So A is connected with all the three and B is connected with all the three. C and D are also connected with all the three. So how many edges are here?
Here
Six.
it's six is there.
6. Similarly, let's say I'm taking only A, B and C. Now,
3.
3.
which is nothing but here, how many, what is the n value? N is nothing but the vertices.
3.
3 into, what is n minus 1? So I have got 3 edges. Similarly here, 4 into 3 by 2, which is nothing but 6 edges. Is it clear, people?
Yes.
So you can take any number of vertices. If that has n into n minus 1 by 2 edges, then that is said to be the clique. Is it clear?
Yes.
Okay. Similarly, here they have mentioned that there are 15 telephone booths. So is it possible to connect with the wires with each telephone booth with exactly 5 on the other telephone booths? Is it possible? All the 15 has to be connected with exactly 5 each 5 booths, which means only 5 edges has to be connected for all the 15. Is it possible?
Yes, ma'am. Connected with 5 edges. Oh,
Only
not
5
connected.
has to be connected
No,
for
no.
all the 15.
No, it can not be possible.
Why you are saying it's not possible? Okay. As I mentioned, what is the
N into n
formula
minus
we
1
use?
formula. We'll use n into n minus 1 formula, I think.
Exactly.
Okay,
Why
okay.
so? Because n is the number of vertices and edges is n minus 1. So instead of n minus 1, here what should I do?
15 into n.
Yes, I have to just give it as
By 2.
15 into 5 by 2.
2.
Are we getting a whole number here?
No.
No.
No, right? We'll get something around 37, right?
Yes.
Yeah.
37.5.
Because it's like 15 into 5, we'll get it as 75. 75 divided by 2, we'll get it as 37.5, which is not a whole number. Generally, the edges has to be a whole number, right? Did we join any edges like half, something like that?
No, ma'am.
It's not possible, right? So it is not a possible way. So that's why here the answer is no. Okay, in this, which is a clique? Which are the vertices form a clique?
3,
3.
3, 1, 4, 5. 2.
Okay, 3, 1, 4, 5 forms a clique. Then
3 also.
repeat.
2, 3.
That is said to be a edge, right? If there is only one value connecting, this is said to be an edge.
There are no cliques, right? No,
Yes.
wait.
Are you saying
One
there
has
is-
a click, 1 and 3 has a click. Only 2. There are 2 clicks only.
Okay, what are the cliques are there?
So there is 1 and 3.
1, 2, 3, ma. This is said to be a clique, right?
Yes, ma'am.
And similarly, these 4 elements are said to be a clique. Because if you take the vertex 2, it is connected with 3 as well as 1. 1 is also connected with 2 as well as 3. 3 is connected with 2 and 1. So we can just take this as a clique. Similarly, you can just take this part also. 3 is connected with 3 vertices. Other 3 vertices. 1 is also connected with other 3 vertices. 5 is also connected with the other 3. 4 is also connected with the other 3 vertices. So this 4 is said to be a separate clique. Is it clear?
So you were looking for a separate
1, 3,
click
5 is also considered as clique? Is it?
because 2 is not connected to 4, right?
Yes.
Yeah, that's why I'm taking this as a separate. Yeah, you
Uh,
can take 1, 3, 5 also because no.
Okay.
Yes, here also it forms, right?
Yeah.
Yes.
Similar
Okay.
with 3, 4, 5 can be a separate clique. 1, 3, 1, 4, 3
1,
also
3,
is
4.
connected to be a separate clique.
And 1, 4, 5 also.
Yes. Is it clear, ma?
Yes.
These are said to be the cliques. Is it clear? Everyone?
Madam, this one clear.
Yes.
But the previous one I go doubt, madam. So previous problem. So I don't understand actually. So here we're not able to read actually. Something is blocking.
Mm.
We're not able to see screen, madam. Something is blocking. Okay.
How about now?
Consider okay, now it's okay. Consider there are 15 telephone booths on the island. Is
Mm-mm.
it possible to connect them with wires so that each telephone booth is connected with exactly 5 other telephone booths?
Mm.
See, that the fractional part you explained, I understood.
Mm.
But here, what is the telling is that fractional part you explained that I understood. Okay, fractional connectivity we cannot do. But
Mm.
what then what is the actually answer for this?
Okay, actually, if it is a 15, okay, so how many possible wires to connect with exactly, like they are asking whether 5 exactly other booths can be connected or not, which means the one vertex, let's say we are taking the vertex A,
Mm.
whether this can be connected with exactly 5. Let's say it's B, C, D, and E, as well as F. Similarly, if I take B, let's say it is connected with exactly 5, we need to check. G, H, I. And let's say this is also connected with the D also. Okay. Now I have to check for all. Similarly, if C is also connected with all the other 5, only 5 has to be connected. It can be of any random order also. So by this way, is it possible to connect all the 15 is the question.
Okay, so then if you want to connect means what is a number? How you can
If
calculate?
I take as a general way, I can just connect all the vertex with it's n minus 1. Like a vertex has to be connected with all the n minus 1 vertices. That is one possibility.
Okay, got it. Okay.
Generalized possibility is that you can just make different connections by using combinations and probabilities.
Understood. So because the previous third sum having some n into n minus 1, so maybe that may be related to this any formula. That's why I confused. Okay,
Yeah,
I got
both
it.
are same formulas just to check whether it is possible or not.
Okay, so which means here we need to calculate that is as per our calculation n into n minus 1 way we can
Yeah,
connect.
that is the way, because n is nothing but the number of vertices into the number of edges divided by 2.
So here 15 is edges. Here what they are.
15 is the telephone booth.
15 is the
So
vertices.
it's
15 is the vertices, right?
15 is vertices and
Yes.
5 is edges.
Yes.
The edges, okay.
Okay, but
And
here directly we can tell now why we are going to the fractional part and we are explaining. That's why I'm just thinking.
Because there is a possibility that 15 can be connected with the 6 also. Is it possible now?
yeah, that's possible now.
15 connected with 6.
90 by 2, which is 45.
Oh, into 6. Okay.
Because I can be able to connect all the 15 with exactly 6 for each telephone booth.
Mm.
So that is why we are using this formula to check is it possible or not.
Ma'am, I just joined a little late. Can you just help me understand the concept behind these cliques?
A clique is nothing but we have to take only the similarities. Let's say from B city, I can be able to go to C, D cities for some trading purpose. Okay, so I can just choose a path. If I have to go to city D, I have a different path, right? I can just go from B to C, from C to D I can travel, or I can just take away the straight path also.
Okay.
So it has to be connected with all the other vertices. That is said to be a clique.
Okay.
Similarly, like very simple way to understand this is a vertex connected with vertex minus 1. There is these many edges.
A vertex connected with vertex minus 1 edges.
It's like
Yes.
a dot is
Because
connected to a
let's
dot.
say there is a vertex A, vertex B, vertex C, and vertex D, and vertex E is there. So if A is connected with all,
Yeah,
C
four
has-
lines. Yes, 4 edges.
Yes. So the number of vertices is 5. It is connected with 4 edges. How about B?
We 1, 2, 3, 1, 2, 4.
How about C?
1, 2, 3, 4.
How about D?
A, B, and then E, 4.
Yes. So for all the cases, it's connected with all the it's, let's say there are 5 vertices, it is connected with the remaining 4 vertices. That is
So
said
we
to
are,
be a clique.
yeah, so we are trying to say that if we have n number of vertices, given at a point or at a time, we can have like n minus 1 edges, coming from all t vertices at the same time, right?
Yes, that is said to be a clique.
That is it. Okay, okay, got it.
Great. Okay, what is the size of the clique here? Maximum size of a clique?
Size of a clique?
Yes. Which means how many vertices are connected?
N minus 1, right?
No, in this case.
Okay.
Not get that much size.
So
If
it
it
is it is 3 for 1, 3, 4, 5, and 2 for 2.
So
I
1
didn't-
and 3 forms a clique.
1, 2,
so
3
1,
forms a clique, right? How many vertices are there?
so yeah,
Three.
3 vertices.
And
3 vertices,
similarly, 1, 3, 4 forms a clique. How many vertices are there?
3 again.
Okay, similarly, 1, 3, 5, 3.
Mm.
And 1, 3, 4, 5. How many vertices?
4.
4.
4.
Okay. 1, 4, 5. This also forms a clique. What is the number of vertices?
3.
3. Am I missing out anything?
1, 3,
No,
5.
I didn't get this.
Yes.
I didn't get this, ma'am.
Okay. So just consider these things.
Okay.
Now, this 2 is connected with the remaining 2 elements. Cut this part. Leave this part. Ignore this part. Only consider this part. Okay. Now tell me, is 2 is connected with all the remaining elements?
2 is connected with 3 and 1.
Yes. How about the other one?
3 is connected with 2 and 3 is connected with 1. 1 is connected with 2 and 1 is connected with 3.
Yes. So this is said to be a clique, right?
Yes, it is a clique.
Okay. So that is what I have written it here. Okay. And next is of 1, 3, 4. Is it a clique? Which means
3,
ignore
4.
all the remaining elements. Just consider these 3. Is 1 is connected with 3 and 4?
Yeah, it is.
3 is connected with 1 and 4?
Yes.
4 is connected with 3 and 1?
Yes, it's a clique.
Yeah. Similarly, 1, 3, 5.
1 is connected to 5. And similar thing with 3 and 5.
Exactly. So this is said to be a clique. Then
Okay.
I'm just taking this whole part. Is it a clique?
1 is connected with 3, 4, and 5. 5 is connected with 1, 3, and 4. 4 is connected with 3. So every vertices has n minus 1 edges.
Yes.
What is the right part you have written? 3, 3, 3, 4, and 3.
These are the edges, right? Or number of vertices, you can say. Number of vertices it is connected. Here number of vertices is 3. Number of vertices 3. 3, 3. Sorry, here it's 4 and here it is 3, right?
Oh, okay.
This is said to be the size of a clique.
Size of a clique. Okay.
Okay. So in this, what is the maximum size of a clique?
Four is the
Yes, 4 is the maximum size of a clique. If I have to convert this to a size of 5, so how many edges need to be connected?
2 and 4 needs to be connected, right?
Okay, only that?
2 and 5 also.
And, 2 and 5 and 1 and 2 as well. 1, 2 are connected already.
1 and 2 is already connected.
Yes.
Yes, that should be fine. All are connected. Yeah, all are
That's it.
connected.
Mm. Okay, so how many edges are required here?
5.
No, how many edges we have did an additional one?
2 more.
Oh, I see. 2 more.
We have created 2 edges to make this whole graph as a clique. Am I right?
Yeah, right.
Yes.
to reach the size of 5 as well. So that is the question given here. In order to get a clique of size 5, how many edges to be added? We can do it in other ways also. That is by using the formula of n into n minus 1 by 2. This is the way to get a clique, right? So how many vertices are here?
Total 5 vertex are there.
5 vertices are there. So 5 into 4 by 2, what is the value?
10.
How
10.
many vertices are here already? This is 1, 2, 3. Let's say this is a 4, 5, 6, 7, and 8 vertices are there.
Yeah,
So
so we need to add 2
10
more.
minus 8, we need 2 edges. By this way also we can calculate it, people.
Excuse me, ma'am.
Yes.
I had a doubt about the end of term exam. I sent you, it's a pretty long doubt. I sent it to you in the chat.
I'll check then. Yeah, what's your doubt, dear?
Ma'am, so because I'm doing all 4 subjects, for the end of term exam, each exam is 1.5 hours, right?
Huh?
Each exam has 1.5 hours of duration, right?
So you're in foundation level. You're asking
Yeah.
about.
Yes, ma'am.
Okay.
So, like, will it be because there are 2 sessions, I think they said, like a morning session and an afternoon session.
Mm.
So, it will be a full day exam, right? Like, it won't be like if I'm doing 4 subjects, I'll do 2 in the morning and 2 in the afternoon, right? That's what they mean. Hello, ma'am. Can you hear me?
Yeah. I'm listening.
Ma'am, did you get what I was saying? Or should I?
If possible, could you please repeat?
Sure, ma'am. Sorry. So, because I'm doing all 4 subjects, I was just wondering, will I have to do 2 subjects on one day and 2 subjects on another day, or all 4 subjects on one day?
I think you'll have to do all the subjects in one day.
Okay, ma'am. Okay. Because they were saying that there are, for one session, only 2 subjects will be done. So I was thinking like, oh, is there a morning session and then an afternoon session? Because I'm doing all 4 subjects. So will I do 2 in the morning and 2 in
Similar
the
with all, right?
They'll
Yes.
send the format for that. Abhi, term has not started. They'll send the format for 4 to 5 days before the exam.
So it will be total 6-hour exam on final. I'm a bit curious to know.
Yeah, you can just refer the grading document as well.
Yes, ma'am. I referred to it, but I wasn't sure like, will I have to do all 4 in one day or
No, 4
See,
in 1.
for me, I just written one time they splitted in morning 2 and afternoon 2, but I appeared for the 2 subjects. So one is in morning session and another is afternoon session. So similar way it will come. So the grouping you got to understood. So how they will group.
Okay, thank you.
Mean shift 1, shift 2. Like
So
that.
it will be decided randomly, or do we have an option to select which subject I go in the morning session or which subject I go into the afternoon session?
That I don't know. That I don't know.
Okay, nice. Okay.
Right. Okay.
But it is sure that all the 4 subject will be held in a single day and total it will be 6 hours.
Yes.
No, but
Okay.
that is only the fixed. For should not appear for more than 4.
Yeah, see,
So what
like
about the 3 subjects?
More than 4 you cannot register.
I do agree, but like other guys, I'm also having the 4 subject in this semester, so I have to take 6 hours, in a one stretch in a single day exam. I thought, it will be, 2 subject one day, 2 subject another day, something like that. But okay.
And I could see one more doubt in the chat. 9.2 question 5. This is discussed, right? Still you have a doubt.
प्रत्येकाचं ना डाऊट क्लिअर करून घ्यायला ते प्रश्नाचं असाइनमेंट असो काही असो.
Basan, I hope now you have, I think the 9.2 question 5 is sorted, right? Or you want me to repeat again?
I think you
Ma'am,
already
I think the
explained that well.
question was before when you explained this.
Repeat karna.
The person who like put the question in the chat box was before you explained these questions. So I think it will probably be all right.
Okay, great. Fine.
Yeah.
Okay. So next is the concept of a popular student with a graph. So popular student in the sense of, let's say a person has scored the highest mark. Will that person be a mentor or a mentee? Do you all know what is mentor and mentee, right?
Yeah. So you'll be mentor.
Okay, let's say the person who has scored the least mark. Will that person be a mentor for any other person for that particular subject?
No.
So,
Exactly. Let's say the person who has scored a mark of 85, that is the highest of all. So he can mentor a student who has who is lying between the range of 10 to 20 marks difference. So minimum has to be a 10 mark difference and maximum has to be a 20 mark difference, which means 65 to 75 range, right?
Yes.
So the person who has scored 85 can mentor a person whose marks lies between these range. Okay, let's say a person has scored 35, which is the least mark. Will this person be a mentor for anyone?
No.
Of course. So he'll be always a mentee and he will be always a mentor. Okay, now who will be most popular? The person who has scored the range between 84 to 36, or this person like 85, 35 people will be a popular person?
85, 35.
85%.
Yes, the person who has scored 85 will be a popular. Similarly, the person who has scored 35 will also be a popular because he will be a mentor for many people. He can be a mentee for many people for that particular subject. Is that thing clear?
Yes.
Okay, so now what we have to do is we have to find, we have to take a first card and we have to check who can be for whom he can be a mentor. Okay, so that is what is this popular students with using a graph here. Yeah, if a person has to be a popular in the sense of he should have a number of mentors or he has to be a mentor for many students. Is that clear?
Yes.
And if the person who has scored the highest mark will be a mentor, he does not have a mentor, right?
Yeah.
So the person who has scored 85 will be a mentor for many, but he doesn't have a mentor. So that's what is given here. Who cannot be mentored? And the next question is, who cannot be a mentor for any student?
The person with the
Lowest marks.
Lowest mark will not be a mentor for anyone. And also they have also mentioned that we have to find a difference between the maximum, minimum of 10 difference mark or the maximum is 20 is the mark difference.
But I think it's for that value then when we have given the highest mark or if we have given a particular mark, how can we say that he's a mentee or he's a mentor?
And also, let's say, if the person has scored 75 to 85.
Okay.
So that person also, because we are taking a minimum difference of 10 to 20, right? Less than, there is minimum 20 and maximum 20, minimum 10 and maximum 20 has to be the difference. What if the difference is less than 10?
mentors to each other, right? So they cannot be mentors to each other, right?
Yes. So if the difference is 10 in this less than 10 in the census, they cannot be different. They cannot be a mentor for each other. The minimum difference has to be 10 to 20.
I'm asking that mentor or mentee is for a single person or a 2 or 3 person.
A person can be a mentor for many person also. One person can have a many mentor also. It's like a one-to-many relationship. One mentor can have many mentees. Similarly, one mentee can have a many mentor also.
It's many to many relation.
Yeah. It can be either ways also. Is it clear to you all, ma?
Yes.
Yes, ma'am.
Great. Now proceeding further. So we have a pseudocode for this as well. See, this is the code. So first is we are creating a matrix. So using the previous code, you can just do that. And we have to find a mark difference. The mark difference lies between 10 to 20 in the sense of the particular person can be a mentor. That is, I can be a mentor for J. Because I has scored 10 to 20 marks higher than the J person. So he is a mentor for that particular Jth person. Is it clear?
Yes, ma'am.
Is it clear to everyone, people?
Mhm.
Similarly, let's say a person has scored a marks like 65, 35, and 90. Okay, the other person has scored 90, 65, and here he has scored, let's say, 80. And let's say the other person has scored 35, 40, and here it's 35. Okay, so in this case, similarly, let's say here I'm just giving us 40 also, something like this. Okay, so here, let's say they haven't given about the mark difference. Then, if there is no mark difference, so who can be a mentor for, let's say this is of physics mark, this is of chemistry, and this is of maths. Let's say this is of person A, person B, and person C. Will person A be a mentor for any subject and for the other people, irrespective of the mark difference?
Yes, ma'am. Person A can be a mentor of maths for the person B and C.
A can be a mentor for B and C in math subject. How about B? B can be a mentor for any subject?
Chemistry and
Physics.
sorry, A and
Yes, for A and C,
in
Yeah.
physics,
he can mentor.
In physics and chemistry, both.
chemistry
And for C,
I think
will
he
C
not.
be a mentor for any subject?
No, she will be only mentee, and B can be mentor in the two subjects, physics and chemistry.
Yes,
Or
chemistry
AC.
also, the person has scored the highest mark.
A and C.
Yes. Let me just give here with comma, chemistry also.
Yes.
Okay, so here B is teaching A as well as C. Can you see here? A is teaching B a max. So, but A can be a mentor for B in some subject and B can be a mentor for A in some other subject. But they cannot be a mentor for the same subject, right?
No.
Yes.
Can you able to understand this?
Yes, ma'am.
I do.
Okay, A can be a mentor for B and B can be a mentor for A in a different subjects, but not in the same subject. Is it clear to everyone?
Yeah.
Yes, ma'am.
Yes, ma'am.
Great. . Okay. So here, let's say ith person and x is x and y person. So who has scored the highest mark here? And what this thing implies here? Just go through the pseudocode and tell me what this implies.
It tells you that only X will be a mentor for Y if X scores 5 marks more than Y in math.
Exactly. Which means I has scored minimum 5, which means more than 5 marks, which means minimum 6, right?
Right.
Yeah, so that is what is mentioned, at least 6 marks. Because more than 5 means it's like, it starts with 6.
Minimum 6.
Minimum 6. Maximum can be any number.
Yeah, but here the assumption is that mark will be an integer.
Huh.
Otherwise, it can be otherwise.
Yeah, instead of I and x and y, here they have mentioned the edges as I and j. That's why here also we are taking as I and j. Okay. And here using a matrix A computed in question number 1, given a student I, what is the return value of the procedure of A comma I? So here it is given as column is taken, I is same, column is changing. If it is equal to 1, count gets incremented. What does it mean? When are we making this A of x comma y equal to 1?
When there is
When
marks is more
it's
than
more-
5, so we are creating the mentor. So it's basically counting the how many mentors are there.
How many
in particular
mentors, or for how many people I is a mentor or C is a mentor?
See, one is defining as a mentor, right?
Yes. So for how many
So
people I is a mentor?
right.
Which means who have scored at least 6 mark less than the I student. Then only they can take it as a mentor, right?
Yes.
Yeah, so that's what is this question. Is it clear to everyone? Please do respond more. Is that clear? Or do you want me to stop so that you can just understand that?
Ma'am, please explain this again.
Okay, fine. Let's say, let me just delete it. Okay. Let's take x and y values here as mentioned here. So if x has scored, x and y difference has to be greater than 5, which means what is the value it implies? Which means if this person has scored 90 and this person has scored 85, will this condition be satisfied?
No,
Which means a minimum, it has to be
84.
84, right?
Yes,
Which means what is the minimum difference? 6.
6.
Only if they have a minimum difference of 6, then we are making a of x comma y to be of 1, which means x is a mentor for y.
Mm.
Is that right?
Yeah.
And let's say its index is 0 and 0. Now, let's say y, we are taking a next person. The next person has scored 50. Then what is the difference between both?
40.
Which is greater than 5 or not?
Yeah.
So a of 0, 1 is equal to 1. Am I right?
Yes.
Let's say the next y has scored only 87. Now,
No.
No.
A is not a mentor for second indexed person. Now, let's say I'm taking the, here it has to be 1, here it has to be 2, because 0 comma 0 is the same, right? Okay, let's say next y person is 12. Now, this person is a mentor, right? What is the difference?
8.
What? 8.
78. 78.
Yeah, which means is it greater than 5 or not?
Yeah, greater than 5.
So of course, the person can be able to be a mentor. Okay. So here A of 0, 3. For that, is 0th index person is a mentor?
Yes.
How? Because the mark is 87, right?
Oh, no.
So for this person, he is not a mentor, right?
Yes,
Can you able to understand this?
Yes, ma'am.
Okay. So now, same thing. We have a different question. That is, we are just only picking. Here I have picked 90 and we have did, right? The same way. Here they taking the 90 and they are counting for what they have got value as 1. For A of 0, 3, what is the value? Still the 0, right? Now, for how many people the 90 person who has scored 90 is a mentor?
3.
Which means 3 people have scored less than 6 mark than this person scored 90, right?
Yeah.
So that is what is the option also. Is it clear?
Yes.
Is it still confusing?
No.
Okay. Can I go ahead with the next question then?
Yes, ma'am.
Okay. So here they're asking I and j has to be equal to 1. J and k also equal to 1. If that is the case, it has to return true. Otherwise, it has to return as false. So what does it mean? Let's say I is 0, j is 1. This is equal to 1 means, let's say j is 1 and k has to be some other value like 2. If both has to be equal to 1, then this method will return as true. So what does it mean? Okay, what is the mark difference of A and B?
At least 6.
Okay, and here?
For
Here
1
also at least 6.
B6, yeah, to be 1.
So what is the difference of marks between 0 and 2?
12.
12.
At least 12.
At least 12 has to be the answer. It is true if the student who has scored at least 12 mark less than I, then this value will be true, right? Is this thing clear, people?
Yes, ma'am.
Okay. So next is concept of connected graph to represent a relationship between the different nouns in a graph. And which means, let's say we have a noun as Swaminathan. And then we have eyes, which is also a noun. And then let's say we have one more as his principal. And stick. These are the nouns. Okay. So how we have to represent a relationship between the different nouns in this. Let's say we have a pronoun as he, it, and something like this. So he can refer to Swaminathan as well as the principal. Is it right?
Yes.
His eyes can be referred. Stick is it. Is this clear?
Mm.
So how the noun is related with its pronoun. So that can also be defined here. Okay, how to connect a noun with its pronoun. So we have to keep checking a card whether it is suitable for this noun or not. You can just check in this video also. Yeah. Is this visible, people? So initially they have taken a pronoun and then they have taken a nouns in a different numbers and then they are trying to map it together. Is it clear?
Yeah.
So 0 is a pronoun. I mean 0th card is a pronoun. It can refer to whom? For the card number 2 and 3. Similarly, card 4 is a noun. It can refer to 10 and 9. So this is how we are trying to define a relationship between the nouns and its pronoun. Is that clear?
So card 0 and 4 are the pronouns, right?
0 is a pronoun, 4 is a noun. So how it is connected with its different noun also.
Okay.
The other word, let's say, I is a noun and he is also Swaminathan is also a noun. So both are connected because the I is refers to Swaminathan I only. It's like that. Hold on then. I'll just take some data card from here. And I have to take a paragraph. Yes.
Everything on the left is connected with it.
Okay. Can you see this? 0 is a pronoun. 0 is pronoun and 9 is a pronoun and 11 is a pronoun. By this way, they have just collected the pronouns differently and nouns differently. Okay. So now they are trying to relate it. 0 is what? It. That refers to the Monday and morning. So that is why 0, 2, 3 are connected together. And next is Swaminathan is a noun. And in the same sentence, his and I's are there. Swaminathan is a noun, that is of 4. So 4 is connected with the 10 and 9. His refers to Swaminathan. I's also it is of Swaminathan's. And then they are taking the pronoun 11. We have to check within the before full stop what are the nouns are there, how it is connected. It is like that. Is it clear?
So they're connecting nouns and pronouns and nouns, right?
Yes, exactly.
Okay.
So by this way, they're just going through all the elements like around 64 cards and they are mapping the noun and it's matching whatever the other noun it is matching with it and whatever the pronoun it is matching with.
Mm-hmm.
Is that clear?
Yeah. Okay.
Okay, nouns within the sentences are connected to each other.
That's false.
Yeah, why it is false?
Within a sentence. No. That's true. Within a sentence. I was comparing
It's
two
always
sentences.
connected, they are mentioning. Is it mandatory to be always connected?
Yeah, I think it is always connected in a sentence.
Yes.
It gets blank somehow. I don't know. In your screen.
How about now? Is it becoming a blank now?
No, that's okay now.
Okay,
But still
I think
some
when I'm
portion is
opening
blank.
a chat box, it is becoming that black.
Oh.
Okay. So now let's say we are taking the Monday as a noun and 13 as another noun. So 13 and 18.
13 and 18. So 13 is Monday and 18 is calendar.
Yes. If there is a it, then it can connect both the nouns, right? But these both are not connected, right? Okay, these both are also connected here. And freedom, Sunday. Yeah, freedom and Sunday are not connected, right?
To the delicious freedom of Saturday and Sunday. They are connected, man.
How freedom is a noun and Saturday is also a noun, Sunday is also a noun. All these are connected to each other.
Yes.
How it is connected to each other, but it can be connected with the pronoun it. Am I right?
Freedom of Saturday and Sunday, the sentence was right.
Yeah.
It's connected to 2.
See, 22 and yeah, 22 is a noun. Is it connected with 24 or 26? No, right? But it can be connected with the 34 noun. No, no, no. Wait. It can be connected with the pronoun it, right? But it is not connected with each other.
Freedom of Saturday and Sunday. Freedom, Saturday and Sunday are, I think, connected.
Huh.
It is talking about the freedom of Saturday and Sunday. They are connected.
Yeah, freedom is a noun, Saturday is a noun, and Sunday is a noun. These three are not interconnected, right?
24 and 26.
No, 23, sorry, 22, 24, and 26. These three are not interconnected, right?
Saturday and Sunday are not connected because there is no relationship between them, I think.
Yeah.
But freedom is connected with Saturday and Sunday.
How we are saying it is connected?
Because we are talking about some adjective of about Saturday and Sunday, right? Freedom of Saturday and Sunday.
But of is not taken because it's a preposition. Preposition. Only we are taking the nouns.
Yeah. I can't say about this.
Okay. But if there is a pronoun named it, then it can be connected, right?
It's difficult to get into.
Okay. Let me just take some other example then. Yeah. Within the full stop only headmaster and cane are connected. Is both are connected? Headmaster is a person, but cane is
Just
a
noun.
object, right?
Yeah, object, yes.
Whether these both are connected here?
Yeah, they are both are connected.
How?
And because it is talking about headmaster's cane. Something with the concept over here. If it is not connected, then I'm missing something. But I
It's
think
not connected actually. It can be connected.
Connected graph.
Actually, it is not connected, right? I think you're just confusing it with whether it belongs to him or not, something like that, right?
yes, yes.
Don't get confused with that. Let's say headmaster is a person, cane is a different object. Okay, so this refers to a pronoun as his or him, something like this. It refers to a pronoun as it. So I can connect this with either of this pronoun, or let's say he has some fire-eyed or some other noun, like if it is something like school, then no, school also will not be connected here, right? His class. So in that case, it will be connected. But Kane and headmaster are not connected. It is connected to a different pronoun or different noun. These both can be connected to a person named Vedanayagam. Right? Is this thing clear? Vedanayagam is the headmaster, only his cane is referred here. It has nothing to do with the headmaster and cane, right?
Okay.
These two are not connected, but it is connected by this way. Can you able to understand this?
Okay, ma'am.
Because this is a different noun and this is a different noun. These are connected to a person named Vedanayagam. The same class can be connected to the Vedanayagam because it's his class. He is a teacher.
Mhm.
Is it clear?
Yes, ma'am.
Okay. So that is how they are just asking whether all the nouns are connected together. So it's not mandatory all the nouns are connected within each other. So its answer is false only. A noun from one sentence can be directly connected to a noun to another sentence. Is it possible?
Yes, it might be possible. Yes, it can be possible, right?
So noun from one sentence can be directly connected to another noun of to a noun of another sentence. I think here it will be like false if I'm not wrong. Because one noun can be like Swaminathan. In the next sentence, it can be like a principal also. Like the Vedanayagam can also be referred, right? In that case, I cannot say the both are connected, right?
Yes, yeah. But it might or might not be connected.
Yeah, they haven't given. They are just giving it can be connected. It can be directly connected. No, it may or may not.
Yeah, so it's false. Yes.
And here they have given payasam is a sweet Indian dish which is prepared from a boiling milk, sugar, and rice. Okay. So what they have mentioned is choose the correct connected graph between the nouns and pronouns. So here we have to just list the nouns first. What are the words are noun here? Card number 0 is a noun. 4 is a noun. 5 is a noun. 11, 12, and 14 are the nouns, right? What are the pronouns? Yes, what are the pronouns are here? Which, right?
Number 6.
Yeah, number 6. Other than that, is there any other card which is of pronoun? No.
No.
So now we have to create a graph in such a way that 6 is a pronoun and all the remaining are the noun. So which of the graph is correct? Yes. Whether this which refers to a payasam?
Yes, it is.
Indian dish.
Okay. How about 4?
Yeah, 4 and 5.
Okay. And then how about 11 and all?
Connected to number 6. Which
Okay. Is 4 and 5 are connected with 6?
No,
How it is no?
because this 6 is connected with 4. It is sweet
0 is
Indian
connected
dish.
with 6. This is right. Indian dish is not connected with the which, right? Because this only refers to a payasam. And for milk, we can say which. For sugar, also, we can say that. And for rice, also, we can say that, right?
Mm.
And this payasam is the Indian dish. This rise and all these are connected with 0, right? So it has to be like this. Yeah, this one can be the correct answer. Because 0 is connected with 6. This payasam is the Indian dish which is connected like made of sugar, milk, for all those things we can use as which. Here, what is the maximum size of a clique appeared in the question number 3? How many cliques can be here? People, can you able to understand this?
3, right, man?
Yes, how it is 3?
0, 6, 11 is 1 clique, and 0, 12 and 6 is a 2, and 0, 14 and 6, 3.
Yes, it's like 0, 11, 6 is a clique, 0, 12, 6 is a clique, 0, 14, 6 is a clique. So we can have a maximum size clique of 3 only. So here the answer can be 3. And how many cliques of size 3 are present? How many size clique 3 sizes are there?
Can you repeat that, ma'am? How many?
People, the same given question, ma. How many cliques of size 3 are present?
How many cliques of size 3 are present? 3.
3. So here answer is 3. Yeah. Okay, so the last is of represent a direct train using a graph and find a route with multiple hops. So multiple hops in the sense of multiple routes. Let's say I have to reach Chennai to Delhi. Or let's take example from here itself, from this lecture.
This is 12.
Okay. So I think the screen is visible, right?
Yes, ma'am.
Yeah. So here you can see, let's say from Pune to Vijayawada if they have to reach. Is there only one way to reach Vijayawada?
So we have this kind of.
Yes, ma'am. If I have to reach from Pune to Vijayawada, how many ways are there?
1, 2, 3, 4, right?
Yeah, I can just go from Pune to Secunderabad, then Secunderabad to Vijayawada is one path, or else I can just take Pune to Secunderabad to Bangalore to Vijayawada. That is also a possibility. Or else Pune to Kanpur to Vijayawada. So these are the different hops, right? I can just use a midpoint and from there I can just take the another train and I can go to the required destination. Am I right?
Yes.
Okay. Similarly, you all know, right? Like there is a pair of trains. One goes from A to B and the other goes from B to A. Just with the one change of number. You all know that, right? People, have you ever traveled in train?
Yes, ma'am.
Then what happened, people? Let's say a train number 12213 is there. It is going from city A to city B. So if after reaching there, there will be a number as 12214, which goes from B to A. Isn't it? But the same name, the train name will be same, just the number differs. Just to,
Yes, ma'am.
just going in the opposite direction.
Yes, yes.
Similarly, here they have a pair of trains using which they can just go from one city to the another city. So here, if I have to go from one city to another city, I can just use the different hops also. That is, as I mentioned, if I have to go from Pune to a Vijayawada, I can just use, if there is a straight train, I'll try to use that. That is, let's say if I have to go from Pune to a Kanpur.
Direct thing which.
So for Pune to Kanpur, either I can take a direct train or I can get down in Nagpur and then I can just board the one more train to Kanpur, right? Am I audible?
Yeah.
Or else we can just take a multiple trains also. Let's say from Pune to Secunderabad to Nagpur, Nagpur to Kanpur is also possible.
Yes.
So this is said to be a multiple hops. If there is a direct train, I'll try to approach it. If not, we'll just go in a different directions. Is that clear?
Yeah.
Okay. And there can be more than one label on. Yes. Any doubts so far, people? Yes. Any doubts? No, right?
No.
Okay. Then proceeding further, there can be more than one label on the edge between the two stations. Is it true?
No, because there can be only one label, right? So label means that this train is traveling between two stations only, right?
Yeah. But is there only one way to reach another station? Or there
Oh,
can
no.
be multiple hops, right?
Oh, there can be
Yeah, multiple.
Yes. So the answer
Okay,
is true. There
so
can
the
be.
label means hops, right?
Yes. There is only one way or multiple ways, something like that. Okay. A station with best connectivity can be identified from the graph by counting the number of edges. Based on the number of
Yes.
edges, we can just
That's
have
Yes.
a best connectivity out of it, right?
true. Yeah.
So here the answer is true. The plotted graph gives the information of the running days. Does that give any running days updates?
No.
Exactly no, because that is mainly based on if I have to go from one city to another city, what are the ways? There
Yeah.
it didn't talk about the days.
Schedule of the train.
Is that clear?
Yeah, clear.
Okay. So assume that there are n different routes to Chennai to Delhi. So how many possibilities are there to choose how many different ways from one to go and come? I mean, front and back he has to travel, right? Let's take a simple example that from A, there are 3 ways. So what are the possible ways for going front and back?
3 ways only.
Yes. Let's say from A to B, he is going through the path 1. He can return in the same one, or he can return in the second path, or he can return in the third path, right?
The answer should be N, right?
Yes, this is onward. This is of return journey. Let's say R. Similarly, I'm just taking the second as the starting. Then for return, what are the possibilities?
The same possibility.
And similarly, let's say onward and return journey, I'm taking the third direction. Now, what are the possibilities are there?
So same way.
So now how many edges, I mean, like how many different routes are there here? 9 different routes, right?
Yes.
Is it understandable, people? Let's say now there are 4 routes. So 1, 4 is possible, 2, 4 is possible, 3, 4 is possible. And onward return journey also we can take 4, right? Is it right, people?
Yes.
So now how many possibilities? If the number of path is, I mean, the number of route is 4, how many possibilities?
16, right?
Yes, which is, So for 4, we have got 16. For 3, we have got 9, which means, what does it imply?
N square. N
Square.
square.
Exactly. So the value here will be n square. Is this thing clear, people?
Yes, ma'am.
To
Yes, ma'am.
everyone?
Yes, ma'am.
Okay. Do you have any doubts so far in the summary of this week 9? Please do respond, people. No doubts, right?
Yeah, ma'am. I haven't been through this week 9, so today I'll do it.
Yeah, so
and
we have to
I'll
go
bring it back
through
to
it,
you
you know,
tomorrow.
by your session. So after that,
Okay. Let's go through this, and if you have any doubts, you can just ping in Discourse as well. Okay.
we don't have access to the discourse, ma'am. How I can have? I got information that, you know, till foundation I will not have the discourse access. Is it true?
I'm not sure.
Okay. Does anybody has discourse access in foundation program?
I have
Yes,
a div- I
yes,
have a general
I
query.
have, but maybe the mathematics course they provided the link. So that time I just enrolled after that. But
Okay.
now current courses I'm not able to see.
Can you share the link? Is it possible for you?
Yeah, I'll share.
Sure.
Ma'am,
Yes.
I have a general query. So I
Yeah.
appeared for the qualifier, yesterday.
Okay. Is it like a reattempt?
Yeah, it was a reattempt for one subject only.
Okay.
So will I be continued in the same batch, or would I have to go to some other batch, like any coming batches?
Could you please check with the support team?
Oh, okay.
Yeah. All right, people. If you have no doubts, you can leave, ma. Thank you.
All right, thank you, ma'am.
Yeah.
Madam,
Yes.
related to that quiz to one problem I need to discuss, madam. So I have some doubts. It is okay if your time is okay, then we can otherwise.
Yeah, please. What's your query in that?
It's related to the answer having some wrong. That's why I'm just thinking. The problem number, question number is that 12, madam.
Do you have a question paper with you? Or do you have any link or something?
Yeah, I'm just sharing now.
Yeah, okay.
I pasted now.
Okay, I'm just checking. Hold on.
Arun, I tried to access this link. They are saying that access blocked. IITM POD discourse can only be used within its organization. I tried to
Yes.
access with the email ID that I have registered with.
You got access?
No, I didn't. I got the error.
Okay.
Access blocked.
I don't know. So
Because
maybe
it can be only used within its organization. This is the error message.
No, you are using IITM email ID or a different ID?
A different ID. IITM email ID I don't have. How I can have?
No, IITM ID only it will work. That's the reason.
I agree, but in the foundation program, they have not provided me, as I believe.
I don't know, sir. I don't know, sir, that one. So maybe you got to check with support only.
How you got it? Can you make it?
No, I have the student ID. That's why I have access.
Yeah, I'm getting access blocked. IITM
No,
POD.
how you got this, email ID of IITMs? From where you got it?
Organization.
Is there any link or anywhere,
in
our dashboard? Somewhere I can check?
No, they will send once you pass the all subjects.
All subject definition, foundation program?
Yeah.
Okay, so I have to wait for that.
Once you pass,
So,
then they will send the email to you. with the email ID, everything.
Okay.
Till then, Discord success will be blocked.
Yes.
No. Once you got the email ID, then only you can enter the discourse form.
Yeah, that's what I said. See, till foundation, they will not give me the email ID. And without email ID, I cannot log in. So it indirectly or directly, till foundation level, I cannot access the discourse.
Yes.
You can put your queries in the groups, that one. That groups they provided access, right? That groups. So that one you can use.
Okay, we'll try.
Is my screen is visible now? Which question you have asked?
12, madam.
No, in this which one?
Maybe you can open, I don't know, all are same only. QDD4, you just open it. So.
Question number 32 you have mentioned.
12,
Right?
question 12, madam. No, you're going page number, I think. So maybe different questions, all questions are there here. All subject questions are there. Just remove, madam, that one search box. So you come by first page.
Okay. Do you remember in which one you have opened and it was
QDD4, madam. QDD4, open it. Yes. Yeah, this one, yes. No, you don't put CT, you can check, no, CT. No, you are opened a diploma one, madam. So you opened a diploma one.
Can work.
Yeah, you okay. I sent the same thing only, but why link is not? Yeah, in foundation QDD4, yeah, and it's a diploma, that one in foundation exam QDD4.
Below.
Yes, this one. And city in front of on second page or third page.
No.
Just go to the first or second page. It will be there.
Okay.
For others. Yeah.
Told some. So yeah.
Hold on, 9, 10. Yeah, here is the 12th question.
Yeah. So here the answer I provided is which means same parts of things, but here they provided the count of sentences. The number of.
We'll check then. So actually what is given is S list and W list is given, which is for sentence and this is for word, right? Because here they are taking a word as well as its parts of speech here.
Yes.
And in do something, they are
Procedure is there.
checking whether it's a noun, they are incrementing the count. And whatever is the W list, that is in the S list. Okay. Yeah, S list contains the number of sentences in the words data set, right?
But in the procedure is there, no? The procedure is filtering only noun. So if the
No,
noun.
this procedure will check with the count. The count is, let's say if the count value I'm getting is 5.
You assume, madam, you are assume your procedure you are getting the return value 0, because if a noun only is counting, if not noun, it will return 0, right?
Okay.
So then if you are putting 0 here, nothing will be incremented here.
No, can you see this question? Like, let's say A is 0, B is also 0. Is 0 greater than 0? No.
Oh yes, then B will not, that execution will not happen, right?
Yes, this steps like step number 10, 11, 12 will not happen. But
Yeah.
how about 13? It is out of if.
Okay.
Which is considered as a common statement, right? How we are considering this 5, 6, and 7. Similar to this, 13 and 14 are considered.
Oh, so this is outside. So the
Yes.
W list will be
Appended to the S list.
okay. Got it, madam.
Irrespective of this condition check.
Got it.
Madam, the same question. If you look at the line number 7 said the word list plus the part of speech.
Yes.
Where in the word list, if you see in the beginning, it's an empty list, right? So empty
Yes.
list is only getting appended with the part of speech. So it means the word list will only have the part of speech.
Yes, it will have only the parts of speech of a particular word.
Particular word.
So that's why here they are taking and they are checking that whether it's a noun or not.
No, that loop is not coming into picture because it is out of the loop.
Okay.
So case list is anyway out of the loop. In that case, it should only happen with the word list. And word list is nothing, only the part of speech.
Yes.
So answer should be only the part of speech. Why it is counting the words in that case?
Which one you're asking about?
Same question.
Huh?
So
They are asking about the length of it, right? Length of the S list.
what will be the length of the S list dependent? Also, that should be the S list is nothing but the part of speech only, ma'am, in this case, isn't it?
No. Yeah, W contains only the parts of speech. But
Correct.
how about S list?
But S list is
What are the
S list
parts
is-
of speech that is added, right?
but S list is not getting appended anywhere, no, in this case.
Why
It's
it
only
is
empty
not
list.
getting appended?
No,
The S
ma'am.
list is equal to S list plus W list. So whatever W list content, that will be get
That will
automatically
become
updated in
the
the
S
S list.
list. Correct.
Yes.
So
So they are asking that how many sentences or how many sentences, right? That is the length of the S list because see, I'll take an example here. Let's just take data set itself. I hope that will be easy. So instead of it, what will be added in the W list? Pronoun will be added, right?
right.
Next is verb. Next is noun. Next is noun.
Yeah.
With this, there is a word with a full stop.
Yeah.
So if there is a word with a full stop, what has to be done? We have to call this A. There is this do something procedure. Here, if it is noun, it will add it. So how many nouns are here?
Yeah. Let's assume number of 2 nouns. But ma'am, it's not getting into this loop, if loop at all. It is out of the loop. See, if you look at the S list, it is out of the if loop.
It is inside this if. If is a condition, right?
Okay.
If block. Only it is not included in this. But the if block which starts here is it is ending here, right? In 15th line. So what happens? It will check whether 2 is greater than 0. Yes. So now the B value is updated to 2. So irrespective of this if condition, this line, these two lines will work because it is outside this if condition.
Right.
So what will happen? Let's say next word also I'm getting 2. Is 2 is greater than 2? No. So
No.
B will not be updated, but still these two lines will work because it is outside the if block.
Okay.
So what happens is S is equal to whatever is this, which is nothing but P, V, N, N will be added.
Okay.
Next time, let's say I'm getting N and N, that will be added. So now what is the length of this? Yes?
4.
How it is 4? This is length 1 and this is of 2. So how length is 2,
Length,
right?
yeah, length 2, yes. Got it.
Which means I have just taken only 2 sentences so far.
Clear.
Okay.
Only that, I think the confusion was with respect to, I think, the braces complete. Okay, understood. Clear. Thank you.
Okay, thank you, madam. I lost the score in this question. Okay.
Yeah.
Thank you. Bye, madam. Thank you.
Yeah, okay, people. Thank you.
Thank you, ma'am. Bye.
Yeah, okay. People, others can also leave.
Yes, sir.